After done checking all the aspects of the connections, now we look back on the questions for this example. The questions ask us to determine the maximum shear resistance of the connections. For us to determine the maximum capacity of the connections, we will need to look into all the aspects and identify which fell first. These are the results as obtained from the calculations from the previous slide. We know that the connections by fundamental, it will be between the columns and the end plate, as well as the end plates and the beam. These are the series of checks that you need to do for the connections between the columns and the end plate. And these are the areas that you need to check for the connections between the plate and the beam. You have checked the edge distance and the spacing, you find it pass. You have checked the ductility, you find it pass as well. You have checked the shear resistance of the bolts, these are the capacity. The bearing resistance of the plates as given here. Since the column thickness is higher than the plate, so you don't need to check for this. If this pass, this should automatically pass. You have also checked for the bolt tearing resistance as given here. Since the bolt used is not pre-stressed bolt, that means the frictional resistance is not required to be checked. As for the welded joint between the end plates and the beams web, you will need to check the weld resistance as given here. Check the shear resistance of the gross plate area, shear resistance of the net plate area, as well as the shear resistance of the web. Based on the result here, you know that the shear resistance of the web is the lowest. With that, you will expect the connections fell between the plate and the beam, which occurs at the shear resistance of the web. That means ultimately the failure is within the web of the beam, where the plate and the weld will tear parts of the web off, leaving the rest of the web together with the beams on the other side. If you compare the value here, you find the shear resistance of the web here is relatively low compared to the others. For you to increase the capacity of the connection significantly, you may need to increase the thickness of the web. By increasing the shear resistance of the web here, it is possible to double the capacity of the connections. As the next possible failure, it will be due to the bearing resistance of the plate, which is 626.4 kN.